I did my presentation on the Poisson distribution, and I'll be talking to you about some data that has a Poisson distribution, what the Poisson distribution is, some data that has the Poisson distribution, and then give you 2 examples of how the Poisson distribution is used. So first off, this is a function of the Poisson distribution, and you would plug in for what your lambda would be and for your data set, and that would be your mean of the data set. And the other parameter that you have to plug in, because you know what E is, would be your X, and that would be, you want to find out what the probability of that X would be. So you'd plug in, say, you want to know the probability that you would get a 2 in that data set, so you'd plug in 2, and then you would get it. And this is a picture of what the Poisson distribution would look like for different lambdas. And it's not a continuous distribution, it's just connected so that you can see it, how it's shaped, but it would be 1 point for every integer. And that's not the full screen, but it's cut off. Don't know how to fix that. But here's some examples of where the Poisson distribution is used. It's used for data that has a common rate of occurrence that is either spaced in the same time or spaced in the same space. So the first picture is cut off, but it's a picture of a bunch of chickens. So if you would imagine a field that is a grid, so you would want to know the rate of occurrence of a single field, how many chickens are in that plot. And another example is how many cars come in through a drive-through at a given time. Intervals, say like 12 to 12:30, and the last picture is a picture of an earthquake. It can also be used to tell you how the rate of occurrence of earthquakes in a given place. And back to the drive-through example. Say you expect 6 cars to come through a drive-through between 12 and 12:30. And what's the probability that actually 9 cars would be coming through during that time interval? So you would figure this out by plugging it into that formula that I showed you at the beginning. So we have a lambda of 6, because we know that there would be 6 cars, and we want to figure out what's the probability of there being 9 cars that would show up at your drive-through. So you just plug it in, and this is an app that I found online. So you just plug in what you know, and you want the probability that it would equal 9, and you would get a probability of 6%.
So I have a question, Paige.
Yep.
What if you have, maybe not with the drive-through example, well, we can just do it with the drive-through.
Mm-hmm.
What if you have a situation where you have a whole bunch of zeros?
Okay.
So you have that pattern, except you have a whole bunch of zeros also. Is that going to have a Poisson distribution, or?
A whole bunch of zeros.
Yeah, so the 0 bar just goes like really high.
Oh, okay. I'm not sure what distribution that would be.
But it would not be, you think it'd be Poisson or no, or? That's okay if you don't.
Possibly, I'm not sure.
Okay, perfect. Go ahead, keep going.
So another example where it would be used is if you would want to find out the rate of occurrence of a certain disease. So this is just a snippet from of the rate of occurrence of Hodgkin's disease for different years, and you can just find this. Well, this particularly at National Cancer Institute website. So I just took a snippet of that. And say that I think this example was in the 1970s, but say you know that 4 people are supposed to die in that group, and what is the percent? You would want to know the probability that only 3.5 of them survived. And you might think that you would want to use a binomial distribution to solve this, because you know people are going to die, and you would know that these other groups of people aren't going to die. But when you think about it, you have this huge group of people, but is the rate of death for all of these people really exactly the same? So the Poisson distribution can also be used for for a large N and you know the rate of occurrence is the same for all of these people for Hodgkin's disease, you don't know the rate of death, but you know that the rate of occurrence for Hodgkin's disease is the same for all of these people, you can use the Poisson distribution to find out whether or not that this new rate is more probable than the rate that we found before, which was 4. We want to know if 3.3 is any more common than 4. So would we use the binomial distribution? It's not really best used in this case. So back to the Poisson distribution, you would want to know, you would plug in 3.3 into the Poisson distribution function, and we would want to know if 4 or more is any more probable, and that would actually be your p-value in this case, and it's 0.4, it's way above 0.05, so no, it's not any more different than having 4 deaths. And you would figure that out by taking like 0, 1, 2, and 3, and if you're doing this by hand in the Poisson equation, and you'd be subtracting what you would get for 0 to 3, and you'd be subtracting that from 1 to get 4 and above. So you could do that by hand. So I shared with you 2 examples of where the Poisson distribution was used and different types of data that have the Poisson distribution.